so now we're going to cover the second part of the shaft that we were dealing with. We pushed the bearing off. Now we have to reinstall. So we're going to use the bearing heater. This one is an induction heater. In the book it talks about bearing heaters and the different types and things like that. The first thing they talk about is why we have to use a bearing heater, because of the interference fit. If we were to measure this shaft and the inside of this bearing should be a little bit smaller by like 1/1000th of an inch, maybe 1.5 thousandths of an inch, than the outside diameter of this shaft. So we have to expand the bearing to get it to slide over there. Right now it's not going to slide over. So most of the time your new bearing is going to come wrapped in plastic. I've wrapped it up in a rag just to keep it clean. The other types of heaters that they talk about, we have the induction heater. They have the electric oven, just like the oven at your house. Just probably a smaller version. You could put the bearing inside there and heat it up to whatever temperature you're looking for. The other type that they talk about is a oil bath heater. That's usually used for big, large bushings and bearings, and it's a big vat or a big tub of oil that is heated up with usually a propane burner. Anybody deep fried a turkey at Christmas time for Thanksgiving? Or it's the same type of concept. They're heating that oil up, and then they're putting the bushing in there or the bearing in there, heating it up to that temperature, and then they take it out and install it in there. Be very careful if you use one of these. I use the example of, I have a hot tub at my house, and we've all gotten in a hot tub. If the temperature's a little warm, if the hot tub's a little hot, mine has a high temperature setting of 104. When you first get in, that 104 feels warm. Remember, we're heating this oil up to 225, 235 degrees, twice the temperature of that water. So how fast is that going to burn you? And the second thing is dry skin. What does oil do to your skin? Soaks in, absorbs. So as that 225, 250 degree oil is burning your skin, it's soaking down through the layers also, which is where people get serious burns from this. So be very careful when you do that. The induction heater is probably the most common and probably simplest to use, realistically. So we have some tools laid out here that we'll use with this. The downside of the induction heat. When we heat the bearing up, it will become magnetized. Now some of the newer ones have a demagnetizer and a switch that you flip and shut so it doesn't magnetize. The old one like this does not. So what I tell everybody, the first thing that you do is you clean the entire area. I took a rag and have already done that. Wipe down the vise, wipe this down. I've put the shaft here, and this is where we're going to with the bearing. It's much easier to keep it straight putting it on vertically than it is sliding it horizontally. We just find some place where it's not going to matter that the jaws are pinching the shaft to hold it. Okay? But we've cleaned all of that. The other thing I've already done, we look for any deformities, anything that is not clean where the bearing's going to set. We don't want to emery cloth too much and reduce the size of that shaft, but we got to get any imperfections off of it. As you see, the back of this has a 240 on it, meaning it was 240 grit, which is the finest grit we had. I think we had 60 and 80 over there, which is a lot more coarse and going to take it a higher chance of taking off metal. Go with the biggest number, it is the finer grit. So we clean that and make sure that everything's going to go. Next, like any electrical tool, we'd inspect the core. The reason I'm showing you guys that, this has some bad spots on it. See how the insulation is melted there. It's not burnt through. And then back here, this is just a little loose. It doesn't mean that it's going to come out and it's bad, but you have to be careful of things like that. And then we would go all the way through the cord and check everything, just like we've done many a times. But I wanted to show you that, so when you use this, you know that that's there. The other tools we have here. It said in the book, we do not heat the bearing over 250 degrees. So we have what are called temp sticks. How they work is they're at a certain temperature. This one down here starts at 125 degrees, then 150, 175, 200, 225, 250. We're going to take the 225, and as this bearing heats up, as it's on there, we're going to rub this against it. When it melts, we're at the 225 degree temperature. We're also going to use the pyrometer and shoot it and make sure our temperature's there. When we use this though, make sure you just shoot the inside part of the bearing. We don't care what the temperature is out here. That doesn't fit on the shaft. This is the only part we're trying to get the temperature of, and that's what people do incorrectly out in the field. Is they're taking the reading anywhere along there and they way overheat the bearing before putting it on. But I want you to get familiar with both of these. If this is short, like this one's not here, we just loosen this up, shake it down a little bit till we get it out there, pull it out, extend it, and then we'll have more again. But I'm going to lay this one here so it's all ready. The other part, we have 2 bars. This one's obviously for larger stuff. It's not going to work, but there are different size bars for heating up different size things. So we're going to use this. It has 2 pins here, 2 holes on the bar that lock it in there. We'll do that. Lastly, what we need, gloves. I laid the different gloves out here. The glove of choice for bearing heaters. We have this bin in the tool room. Find the cleanest pair. Everybody's used welding gloves for all kinds of applications out in the field, and there's all kinds of stuff all over them. Find the cleanest ones. These aren't going to do you much good, and even these leather gloves, it's going to be too hot for it, because we're going to take this up to 225 degrees. So at this point, I've inspected the cords, done everything. Oh, and the last thing I wanted to mention, why do I have it all here? As soon as I get it to 225 degrees, I want it as close as possible to what I'm putting it on. So when I flip this switch off, lift this up, pull the bearing, it's as quick as possible to that. I don't want to heat it up over here, then have to walk all the way over there and have it cool down on me as that goes. Now this could be a little time consuming with this, because it's going to take a little while to heat it up to the temperature. Oh, step 1, plug it in. Turn your switch on. Now I'm just putting these gloves on right now because it's not hot, but I'm going to center that bearing in there so that it stays away. See, I don't know if you can see in the video, but it's spinning around on there. It's heating the whole inner ring or inner race at that way. If it's not spinning, if it's stuck there, just rotate it every so often. And you see the magnetization is trying to pull it closer to the side as it does. Now I'm going to get my other gloves out and get them ready. I know I'm not at the temperature yet, but I've come up almost 10 degrees in probably 20 seconds, something like that. So it's going to take a little while to heat this up, but not terribly long. They'll say in many, many cases, cleanliness is next to godliness. Bearings especially. We don't want to get any contaminants in the rolling elements of the bearing. That's what ruins it. So we want everything clean as possible. The other thing, like I say, these will get magnetized. So if there's little pieces of metal from being around a grinder, being around a bandsaw, being around a lot of these tools, as we go over there, it would pick those pieces of metal up and possibly go in between the shaft and the inner race, in between the rolling elements and the outer race. While that's heating up, quick lesson. What it's rotating on is called the bore. That's the opening that the shaft goes through. This part right here, where the balls roll on inside there, is called the inner race. The race is always designated as the part of the bearing where the rolling elements roll. On the outside there, where it rolls against the outside, would be the outer race. Again, where the rolling elements roll up against. And then this would just be the outer ring, the inner ring, where everything rides on. And then this little assembly that holds the balls in place is called the cage. Let's see what our temperature is getting up to. See how the magnetization has worked again. And I put it on the wrong hand, trying to just get it away from there, but we're up to about 120 degrees. Looks like my batteries are dying in my temperature gun. One real quick thing on the temperature gun. Make sure it's on Fahrenheit and not on Celsius. 200 and some degrees Celsius is a lot hotter than 225 degrees Fahrenheit. $145. So we still got a little ways to go. And as I say, that's going to keep doing that, so have your gloves on ready. We start putting this up there. Obviously it's not melted yet. But to show you how it works, here's the 125 degrees. See how it's melting along there right away. I don't know if you can see that with the, but you can see a little bit of the smoke rising up if you're here in with it. So, like I say, that will melt. Most people are going to use this. It's the easiest way, but remember to shoot the right location. Here's the 175. See how it's melting? We're getting close now. A lot of times out in the field, if I get it to 200, I'm going to try it. Because if it doesn't need to go any higher, why go higher? So I'm going to have the camera move back. I'm going to shut this off. I'm going to pull this, bring this straight over here, and slip it into place. If it hung up, the first thing I'm going to do is get it back off of there, put it back on my heater for some more heat. If it goes all the way on, pushes down against there, and that's the other advantage of doing it in the vertical manner, where it pulls down. I'm going to ask the camera to come up close. When we push this off, I'm going to show you the damage that we had on these threads. That's why we can push on those threads on the press and not have a brass plug or a piece of block in there, because this shaft is already damaged. And that's kind of why we keep it to put the bearing on and off. But in real applications, we wouldn't push on that. The last thing I'll have you guys do, because this needs to cool, we'll cover the bearing. In a real application, we don't want to take the chance of any contaminants getting in there, because at this point now, we need to let it cool down. And now is a great opportunity to make sure you clean all your stuff up and put it away. So, if you have any questions, text me, email me. Thanks.